have like always another define called shift, which says how many bits up is it shifted, from bit 0. So any bit, it's almost always, the name of the register underscore the name of the bit as it appears in the data sheet underscore mask, to indicate that we want a bit mask. And the reason they do mask is because, all masks, because they just have bits set in there, if we can do silly things like that, where you can OR masks together to set multiple. And just to remind you, let's say we wanted to clear those bits. Clearing you always do with the ANDing of the negation of the masks. We may have to make another video for that. But just to remember, setting is ORing with mask. Clearing is ANDing with the negation of a mask. And masks are nice because you can OR several masks together to kind of get a composite a composite mask. So that's kind of the header file. Now, one other thing I do want to show you really quick is that in some cases you may have a bit field that spans multiple bits, and a good example is I just happen to know, for example, in the flex timer module, you notice here that the flex timer module, there can be many flex timers in a Kinetis. There's several of them, like there could be several UART. So there's a status and control. Anytime you see a little X, what that generally means is you can kind of fill the number. So if I hit an FTM and hit control space for completion, let's say I want the first flex timer. Or I'm sorry, flex timer 1, which is actually the second. I'll do that underscore SC for the status register. Well, in the status register, you notice there's this prescaler, and there's this clock select. There's a couple different options for that. It's like a 2-bit value. Well, what you can do is they have a 2-bit mask. So FTM1, I'm sorry, I'll do FTM. In the case where there is multiple versions of the same register, for example, there's more than one flex timer, bit fields don't put the number at the end of the register. So there isn't a bit field for flex FTM 0 and 1 for some of those registers. So I believe it is FTM1 SC. Then you notice there is a generic macro that takes an argument. Well, what you can do in there is, let's say you want to select for the clock source selection, external clock, that is a 1-1. That's the same as a 3. That's all you have to do. Now, if we go to the header file and look at, what in the world is that? I might have to go backward. The header file has some actual magic to make that happen. Here is the macro that takes an argument. Okay, the argument is all the way in here. Now, there's some weird casts, but because the clock select, we notice it's bit 3 and 4. Well, the first operation after this cast is a bit shift up by this value here of shift. Well, that value of shift is 3. That makes sense because 3 bits up. Then the other thing it does, it ANDs that value out with this clock S mask. All right, clock S mask, is an 18. And what that does is, we don't want to muck with any other bits, in this register. So after it does the shift with the value you want to put in that register, it essentially ANDs out any other value. So if you put a value, this is a 2-bit value. So if you put something other than 0, 1, 2, or 3, this macro expansion would ensure that you're not going to play with any other value in the register. So that gives an example of kind of how you use the header file. Just remember that you can kind of directly use the register names. There's bits already defined for everything, so you never have to directly know where anything is in memory. And it gives a nice kind of generic way of talking to the hardware.